Hello everyone. Today's topic of discussion is set theory, and set theory we have done with the three parts already. Now today we'll go for the fourth part. In the fourth part we'll discuss about some of the problems from your book only, that is R.S. Agarwal, and we'll go through the chapter wise problems, not from every chapter, because we have already done with the some types of problems in the previous video. So we'll go through some of the newer problems and newer concepts which will be used, not new new formulas actually. We are going to use the same formulas for problems here. So hope you will enjoy the video. Let's start with the set theory part 4. Set theory part 4. So first we'll start with some of the proofs which I have gone through, which I have seen actually in some of the books. It is given so many times on almost every books. So first of all we'll write the problem here and we'll try to solve it by using the rules what we have already discussed. So this is how we need to prove that A minus B union C is equal to A minus B intersection A minus C. So we can do the proof by taking left hand side or right hand side, any of the sides. So let's take the left hand side here. So A minus B union C. So we have seen in the last video that we can replace, if we have A minus B, then we can write A intersection B complement. So the same formula if we apply here, then it will become that A intersection B union C complement. Now that means B complement intersection C complement, because that comes here by De Morgan's theorem, by using De Morgan's theorem. So now by distributive law we have that A intersection B complement intersection A intersection C complement. Now what does it mean? The same formula, if we apply the same here, then it will become A minus B and it will become A minus C. Hence the proof is done. So here we have to write that we are using distributive law. Let me tell you once again that in each and every step, whatever law is getting used, that has to be mentioned. Otherwise, you lose the marks. In each and every step, whatever laws you are using, that has to be mentioned like this. Otherwise, you will lose your marks. So I think the problem solving here is quite easy, and it is till now it should be clear to all of you. Now we'll move to the next problem. So next problem is A union B minus C is equals to A minus C union B minus C. So okay, so we'll take again the left hand side. This is problem number 2. Now A union B minus C, the same rule will be used here. We can use intersection C complement, as we have seen that A minus B equals to A intersection B complement. The same rule is getting applied here. So now by using distributive law, we can write that A union B, that means A intersection A intersection C complement union B intersection C complement, which is very easy to determine. Distributive law, I'm not writing it in full, but you have to write it in full. So by applying the same law, we can write A minus C union B minus C. You can see and compare. So this is how these problems can be done very easily. And you can see that the same laws are getting used again and again. So you need to remember the name of the laws, and you need to remember how to use those laws in problem solving. So we'll move to the next problem. A minus A intersection B is equal to A minus B. We need to prove this. So we'll start from the left hand side, that is A minus A intersection B. So again we are using the same law, A intersection B whole complement. So it will become A intersection, by using the De Morgan's law, A complement union B complement by using De Morgan's. And here also we need to write the law, De Morgan's. So by using distributive law, A intersection A complement union A intersection B complement by using distributive law. So A A intersection A complement, that means the universal set, right? A intersection A complement. A intersection A complement, that is phi. A intersection A complement, that means the common parts between A and A complement. There should not be any common part between A and A complement, so it will be phi. Now union A intersection B complements. If we do union with any set with phi, union of any set with phi, then it will become that set only. So A intersection B complement. Again by using the same formula, A minus B we can write. So this is how it can be proved. So it is also quite easy to understand. Write it down if needed. Pause the video to note it down. We'll move to the next problem. Number 4. So it is given that if A equals to 2, 5, by using the Venn diagrams. Now we'll move to solve the problem by using the Venn diagram. It is 5, 7, 9, 11 and 15. That is union 2, 3, 5, 7, 9, 11, 13, 15. Now if we would like to verify that if A union B in complement is equal to A complement intersection B complement, whatever you write, you can write it like this. So this is the De Morgan's theorem actually. So we are going to prove the De Morgan's theorem by using the Venn diagram and the given data. So it is given that A and B. So we'll first find out the value of A union B. We can use it by we can do it by using Venn diagram, as the problem stated that we need to use the Venn diagram. So we'll use the Venn diagram. So let's see what is the common part between these two, 5, 7 and 11, I guess. Yes, I can see it properly. Okay, we'll do it once again. 5, 7 and 11. These are the three common parts, 5, 7 and 11. And what are the parts of A? Let this be A, let this be B. So it will be 2 and 13. 2 and 13. The B, where is the B? 9 and 15. So it will be 9 and 15. And this is the universal set. Now what are the things left out? 2, 3, 5, 7, 9, 11. 2, 3, 5, 7, 2, 3, 5, 7. 2, 3, 5, 7. 9, 11. What is the thing? 9, 11, 13, 15. 2, 3, 5, 7. 3 is not there in both the sets. 9, 11, 13, 15. All are there, but 3 is not there. So 3 will be in the outside of A and B. So A union B means we have to consider the repeating parts only once. So what will be A union B? What will be A union B? So A union B will be, we can clearly see that 2, 5, 7, 11, 13, 2, 5, 7, 9, 11, 13, 15. 2, 5, 7, 9, 11, 13, 15. Now what will be A union B complement? A union B complement. We know there is no actual need of writing this, because we can easily determine that A union B means all the sets, all the parts which are included within these two circles, and the parts which are not included in the circle, that is A union B intersection, A union B complement. So what is the part which is not included in A union B? That is 3. So we'll write it down here. So the thing which comes out here, that A union B whole complement is equal to 3. That is the value of left hand side. Now for right hand side, this is the value of left hand side, and now for right hand side we'll take A complement and then intersection with that B complement. So A complement means the part which are not included in A but the part of the universal set. Here, what are those? The part which are included in not included in A but part of universal set. So which are included on A, we need to get rid of them. So 2, 5, 7, 11, 13. 2, 5, if we remove 2, 5, 7, 11, 13, so then what is the thing which is left out? 3, 9 and 15. 3, 9 and 15. Now what is the part which are not included in B? So we have to get rid of all the parts which are present in B. So 5, 7, 9, 11, 15. 5, 7, 9, 11 and 15. 11 and 15. So what are those? So 3 and 13. 3 and 13. So what is, now we have to compute the intersection in between them. So that is 3 and 13, intersection in between 3 and 13, that is 3. Right. So we can see by using the Venn diagram also that A complement means the whole part excluding this A, and whole part excluding this B is B complement. There is only one thing is in common, that is 3. So we can see easily that compare both the sides, that LHS is equal to RHS. So we can conclude that the Venn diagram, given statement, that is A union B complement is equal to A complement intersection B complement, which is absolutely true. So note it down if needed. We'll move to the next one, that is from R.S. Agarwal. So before going to that problem, we'll just discuss about some 2 more formulas actually. We have which we are going to use in the problems. We can write it like this: n of A minus n of A intersection B. Now n of B minus A is equals to n of B minus n of A intersection B. These are the 2 formulas. Please note it down because we have not discussed about the same. Actually, these are the formulas which these are the formulas which have been derived from the formulas we have already discussed, but these are the direct ones, so that we'll be able to use it in problem. So we'll move for a problem. Please note it down. We'll just move for the problem. So let's start with the first one, that is, it is being stated that A and B are 2 sets such that n of A is equals to 24, whereas n of B is given as 22, and n of A intersection B is given as 8. Now we need to find that n of A minus B and n of A union B and n of A B minus A. So we'll find one after another. So we have the formula, that is n of A union B is equals to n of A plus n of B minus n of A intersection B. Now we have all the values here, that is n of A, n of B and n of A intersection B. So we can easily put the values and find the required solution. So n of B is 22 minus 8, that is 46, I guess. 46 minus 8, that is 38. So we have found the value of this one. Now we'll go for the next one, the formulas which we have written just now, just before this problem we will be using those formulas, that is n of A minus n of A intersection B. So n of A means 24 and n of A intersection B means 8, that is 16, and n of B minus A is equals to n of B minus n of A intersection B. That is 22 minus 8. That will be 14. This is how this can be calculated. It is very easy if you know the formula. So remember the formula. Otherwise, you won't be able to solve these problems. Now we'll move to the next one. Note it down if needed. So we'll move to the next problem, in which it is being stated that in a group of 50 persons, 30 like tea. There is a group of 50 persons. 50 persons, 30 likes tea, and 25 like coffee, and 16 likes both. 16 likes both. Now we need to find that how many of them like either tea or coffee. Either tea or coffee. First question is like this. The second part states that neither tea or coffee. Now how to find this? So there are 50 persons in which 30 of them likes tea and 25 of them likes coffee and 16 like both tea and coffee. So we can take tea as T, we'll write it as T, coffee as C. So we have a formula that N of T union C is equals to N of T plus N of C minus N of T intersection C. That is T intersection C, right? Because both of the thing they like, tea and coffee. That is the common persons who drinks both tea and coffee. So in the first question we have to find that the persons which like either tea or coffee. Either means union, because either means what? It is present on A or B. So A or B means what? We need to take the combination of A and B, so it will be A union B only. So N of T union C, that means we have to find, if we have to find that either tea or coffee, then we have to compute N of T union C. That is, N of T is given as 30, N of C is given as 25, and N of T intersection C is 16. So it will be 55 minus 16, that will be 39. So 39 people are like this, those who drinks either tea or coffee. Now we are done with the first part. Now we have to calculate that the people who doesn't drink any of these, that tea or coffee. So be very careful about calculating this. So many students do the mistake that they do find tea or coffee. Neither tea or coffee means they will go for intersection part. No, it is not intersection, because we have already found that 39 people out of 50 people drinks tea or coffee. So remaining people does not like any of the product. We need to be very careful about this. So I will repeat it once again, that out of 50 people, 39 people, because we have found the T union C, tea or coffee both. So the people who drinks either tea or coffee, we have found out the number, and the number is 39. So the people out of 50, 39 are drinking tea or coffee. So the remaining people does not drink any of the drink. It is very clear. Be very clear about this, otherwise you will do the mistake. So it will be 11 people. So 11 people are such that 11 people are present in these 50 persons, those who doesn't drink any of the drink. So this is an important sum. So please note it down and try to understand the concept very carefully. Okay, we'll move to the next one. Okay. Next sum is a very important sum. These type of sums regularly come for the examinations. So be very careful, be very conscious about the sums. So it is stated that in a town of 10,000 families, it was found that 40% of the families buy newspaper A. So 10,000 people are there, 10,000 families are there, sorry, in a town. So it was found that 40% of that population reads newspaper A, and 40% of the family buys newspaper A, 20% buy newspaper B, 20% buy newspaper B, and 10% buy newspaper C, 10% buy newspaper C. It is given. Now 5% buy A and B, both. So that is A intersection B, number of, sorry, A intersection B, that implies to 5%, both A and B. A, they also buy A, they also buy B. That means the in common part, intersection, and it is given that B and C is equals to 4%, and A and C is equals to 2%, and 3%, 2% of them buys all the newspapers. This is 3 and this is, sorry, this is 3 and this is 4%, and this is the percent which does not buy any of the 2% buys all the 3 newspapers. We need to find, first question is, we need to find the number of families which buy A paper only. Then on the second part, none of A, B, C. Okay, second part we'll find B only, and then the third part we'll find A, B and C. None of A, B, C. So it is given that in 10,000, I'll repeat the question once again, that it is given that in a town there are 10,000 families. Within that 10,000 families, 40% reads newspaper A, 20% reads newspaper B, and 10% reads newspaper C. And there are 5% people who reads A and B, both the papers, and 3% people who reads both B and C papers, and 4% people who reads A and C, both the papers. Now we need to find out, and it is also given that 2% people who reads all the 3 newspapers. Now we need to find out the value or the people who reads all the first we need to find out that the people who reads the newspaper A only. Then we need to find out the people who reads newspaper B only. Then we'll have to find out the people who reads the newspaper C only. So let's start with the first part. So A only, we need to find the value, find the number of families who reads the newspaper A only. So in this problem we need to use the formula which is like this: C complement, that is equals to n of A minus n of A intersection B minus n of A intersection C plus n of A intersection B intersection C. See, this problem can be solved in 2 ways. 2 ways means, first of all, we can find the number of families by using this percentage, or else we can just calculate with the percentage and find on getting the final percentage whatever for the required result, then we'll apply the percentage with the total number of families. So we'll opt for the second one, as I think that the second one will be easier, because finding all the percentage, then we'll have to use those percentage again, so it will become a lengthy procedure. So we'll use the second one but we'll calculate by using the percentage only, then we'll impose the percentage whatever we are getting as a result, that on the number of families. So this is the formula which we are going to use, because A only, we need to find out the people, those who reads the paper A only. That can be found out by using the formula n of A intersection B complement and C complement. B complement means what? The people who are not present in B, and C complement means the people who are not present in C. So the formula which is written here we have to use that. So n of A, we have the value, let it be 40. Now n of A intersection B, that is 5, n of A intersection C, that is 4. Now n of this one is 2. So it will be 40 minus 9, that is 33. 33% of the people reads only A paper. We need to find in number of families, so that will be 10,000 into 33 by 100. So it will be 3300. So 3300 families are there who reads only paper A. The same concept can be used for B. I am not going to do it. You just do it by yourself and check the result. B, it will be B A complement intersection C complement. Write down the formula by yourself by seeing this formula and do the calculation part. Now we will move to the third part. Third part, it is being stated that A, we need to find the people, those who does not read any of the three newspapers. So we have a formula called N of A union B union C. That means what? We have done the calculation in the previous problem for tea and coffee problem, that the people who does not drink any of the two products, tea or coffee. Here we need to find that the same concept is getting used here. We need to find the number of people who does not read any of the three newspapers. So first of all, we need to find the number of people who reads any of the three newspapers. Then we can find the number of people who does not read any of the newspaper. So for that we have a formula, that is n of A, n of B plus n of C plus minus n of A intersection B minus n of A intersection C minus n of B intersection C A intersection B intersection minus n of A intersection B intersection C. So we'll just put the values, that is 40 plus 20 plus 10 minus, that is 5 minus 3 minus 4 plus 2. That is 70 minus 10, that will be 60. So 60% of the people reads any of these newspapers, A or B or C. So what is the complement? So n of A union B union C whole complement, that is equals to 60, 100 minus 60, that is 40% of the people who does not read any of the newspapers. So 40% means out of 10,000 family, 40,000 means 40% means so there will be 4,000 families. 4,000 families who does not read any of these three papers. So be careful about the calculations and be careful about the formulas. Then only it will be easier to solve the problems. Please note it down if needed. So we'll move to some short questions, some proving type of short questions here. So let's start with some proof type of short questions which is given in your book. The last exercise, it is being stated that let us take, this one is very interesting. Let us take that n of A is given as 3 and n of B is given as 5. Now we need to find the maximum number of element in A union B. Maximum number of element and minimum number of element of A union B. This is a conceptual question. The concept must be clear to find out this. First, maximum number of A union B. A union B means what? There can be any element, right? There could be common, there could be intersection part, there could not be intersection part. We don't have any idea about this. But in case of finding out the maximum number of elements present in N, we have to consider that there is no intersection part. That means we have to consider that A intersection B is equals to 5. That means there is no part called intersection B has no element in it. So we can use the formula that n of A union B will be equals to n of A plus n of B. In this condition only, the number of elements will be maximum in A and A union B. So that will be 5 plus 3, 8. I think this is clear. I'll repeat it once again, that if we have to find out the maximum number of elements present in A union B, then we have to consider that there is no any common part between A and B. So that, because the common part gets subtracted, in the formula we have seen that. So if we want the maximum value, then there should not be any common part. If common part is there, the value will be getting subtracted, so the value will be decreasing, right? So in case of finding out the minimum, we have to maximize the common part. The simple concept. We have to maximize the common part, then only the minimum value will come out. So in this part, we can see, by observing these two values, we can see that the maximum common part could be 3, because these 3 elements could be common with this, because 5 cannot be the common elements. 5 number of elements common, that cannot be 5, because it has a number, A set has only 3 elements and B set has only 5 elements. So maximum number of common elements between A and B can be 3. So that could be the formula of A union B, minimum of A union B, that can be n of A plus n of B minus of n of A intersection B. So that is 3 plus 5 minus, this is the maximum number of common parts, that is 3, so it will be 5. So this is how it can be solved. Please try to understand the problem, the nature of the problem, then apply the formula accordingly and use the concept accordingly. Then only it will be easier to understand the problem and to solve the problem. Now we'll go for the last sum of today's video. So this one states that we need to find that 8, I guess, whatever the number. Okay, we'll do 2 sums actually. 8. A equals, it is given that A equals to 2 comma 2. Now we need to find the P of A. P of A means the power set of A. So we have gone through the formula that if n number of elements present in a set, then there should be 2 to the power n number of elements present in the power set. So here two elements are present in the set, so that is 2 to the power 2, that is equal to 4 elements should be there within the set. So what are the 4 elements? So P of A will be, don't get confused by seeing this set, so it will be 2, just write it down once again, and first of all this one individually, then the set itself, or you can write it just simple A, or you can write like this also, 2 comma 5. 5 is a subset of every set, that is the number of subsets possible for this set. So don't get confused by saying this. Now we'll move to the next problem, that is it is given that we have to prove that A intersection A union B complement is equals to 5. A intersection A union B complement is equal to 5. Okay, it's complement. So we'll move from the left hand side, that is A intersection A union B complement means what? A intersection, that we can write it as A intersection. Okay, we will not remove the intersection sign. You can use the De Morgan's theorem here. So A intersection A complement intersection B complement by using De Morgan's. Now by using distributive law, A intersection A complement and intersection A intersection B complement. So what is A intersection A complement? There should not be any common part. Now phi intersection A intersection B complement. If we find the common part between any set with phi, so that will be phi itself. So it is proved. So this is how we can solve the problems of the set theory. I think this is the last part of the set theory, because we have already discussed about almost every type of problems and every type of formulas which we will be using in the set theory chapter. Now, if any problem arises, then we'll discuss it in a later in a video. Otherwise, this will be the last video for the set theory. Hope it has helped you in a broader way. So go through all the videos carefully and do the sums, do the calculations by using the formulas carefully, and read the questions before solving it. Read the question again and again if it is confusing you, because there are several questions which can be done by using very short tricks, very very small formulas, very small concepts. So you need to go through all the concepts, all the formulas and all the theory parts very carefully before problem solving. So hope you'll enjoy this video, and see you soon for the next.